Hello friends, myself Sils Joseph and I am here to take the class for class 10, chapter 1, forces and moment of force concept. Isn't it? So in the last section, we have discussed about the concept of moment of force and we have discussed how to find the moment of force and what are the factors on which the moment of force is depending. Isn't it? The turning effect taking place on rigid body. That is the concept of moment of force. So moment of force, we know that it is directly proportional to the applied force and also proportional to the distance of separation between the action of point of force and the turning point, isn't it? And one more thing, what about the direction of this moment of force, which means in which way the turning will take place, and that's depending on the concept point of action of force and also the line of action of force. On that basis, we can classify the moment of force into two. One is called anti-clockwise moment and the other one is clockwise moment. Okay. So for that we just consider a rigid body. Just call it as A be a rigid body, and we can consider a turning point that is called O. This is our turning point. So if you apply a force somewhere on this rigid body, definitely with respect to this turning point O, the body will make a rotation. So now just take a point of action. Let P be a point of action, and we are applying a force in this direction. A force F being applied on this point P. And the line of action of force, you know that what is line of action of force? The imaginary line is drawn in the direction in which the force is applied. So this is our line of action of force. So for this case, the body will make a rotation definitely because we are applied a force around this particular turning point. So the body will make a rotation, and the rotation will be definitely in this direction, isn't it? So when we apply a force F on this point P, the line of action is acting in the upper direction, so definitely the rigid body will make a rotation around this particular turning point, and the rotation will be in this direction. And clearly we can see that this direction is anti-clockwise. Such type of moments are called anti-clockwise moments. Same manner, if you consider another case, just call B. Let's consider a point here. Let's call this O, be the turning point here, and we can apply a force B. We are applying a force F at the point Q, and the line of action of this force is in this direction. And here also, the force is acting on this point Q, and the actual force is in this direction. Okay, and as a result, this body will make a torque, which means the body will undergo a turning around this point or this turning point, and that direction will be this one. Clearly, you can see here the direction is similar to the clockwise motion. So this type of moments are called clockwise moments. Okay? So the direction on a particular rigid body on the application of force can be two types: anti-clockwise moment or clockwise moment, which means the direction will be in anti-clockwise direction or in clockwise direction depending on the point of action of force and the line of action of force. Clear? Then always we will consider anti-clockwise moments are positive moments. Positive moments, and clockwise moments are considered as negative moments. Clear? Anti-clockwise moments are always considered as positive, and clockwise moments are considered as negative moments. So that's about the direction of moment of force. That's depending on two factors: the point of action of force and the line of action of force. Clear? And the unit. Clearly we know that unit of torque is Newton meter, because torque is equal to force into the perpendicular distance of separation. So force Newton is SI unit, and for distance it is meter. So the unit of torque is Newton meter. Okay. So many examples we know about this moment of force, and we have discussed this moment of force detailedly, and we are now going to the further case. Just consider if you want a high or a large turning effect on a rigid body. So definitely we know that if the force increased, definitely the turning effect will be more. So further we go into detailed case. If you want a large turning effect on a particular rigid body, we can apply two forces, and there is one specialty for these forces. These forces must be equal and opposite. Okay, if we apply equal and opposite force on a rigid body, the turning effect will be more when comparing with a single force concept. Are you following this case? And that effect is called coupled of force. Okay. So let's consider the case of coupled here. We can take an example, that is wrench. You may aware about wrench in automobiles, workshops and all that, they are using wrench, isn't it? And wrench, so that coupled wrench, we know that it is used to remove a tightened nut from a particular device or something like that, automobile. For that we are using a wrench there, isn't it? So just consider it's a T-shaped one. Two handles will be there, like this there. There we will apply two forces. Their nature is they are equal in magnitude and opposite in direction, which means you can apply force F in this direction and a force F in this direction. So the magnitude of the force seems to be same, but they are acting in opposite direction. So the line of force of these forces are not passing to the same point, they are different, they are parallel to each other. And that manner, there will be a turning effect will be there in the same direction of the forces. Clear? Such a manner, the turning effect on this particular nut due to this wrench will be more. And that's the concept of coupled. So in definition, we can say two equal and opposite forces acting on a rigid body, such that the line of action of force is different for the forces will constitute a couple. You can see the line of action of the forces are different. They are not in the same direction. They are parallel to each other. They are not passing to the same point. So that's a definition for coupled. Two equal and opposite forces acting on a rigid body, such a manner the line of action of the force is different will constitute a couple. Now we can move to the mathematical expression for a couple. So for that, first of all, we just consider a rigid body. You can consider a rigid body O. This is our rigid body O, and we are applying two forces. They are equal in magnitude and opposite in action. Okay. So you can consider 2 points, A and B. Okay, let a point O be the center, which makes the turning point. Okay, so it is started here by ordering this point, and this is our turning center. Okay. Now 2 forces are acting on this particular one. Here, a force F is acting in this direction, the upper direction. The same manner on the point B, another force is acting in the downward direction, and the magnitude of forces seems to be same. Clear? And with this point, 2 points A and B, we can consider the line of action. And for A, the line of action will be this one. You can call the name X dash. Be the line of action for the force A, for the point of action A. Then for the case of point B, the force, line of action of force can be considered in this direction, that is Y dash. So you can see 2 forces equal in magnitude, but they are acting in different direction, in opposite direction. Their line of action of forces are X dash and Y dash, and they are parallel. Okay. Now we can consider definitely due to this force F on the point A, it will get a clockwise movement in this direction, and due to this one B, definitely it will also get a direction, the clockwise manner in this direction. Clear? Now we can calculate the total moment. So for the total moment force for the point, when you consider the point A, definitely a moment will take place, and that moment can be found by taking the product of force and the perpendicular distance. That is moment on A. A moment at A can be written as force into OA, the perpendicular distance OA. Clear? And for moment at B, can be written as the force acting on the B, that is FOA. F into the perpendicular distance, that is OB. Clear? So the total moment taking place on the rigid body will be equal to sum of the moment taking place on the point A and B, that is F into OA plus F into OB. Clear? So from here we can rewrite just F into OA plus O. Yeah? Then what is this OA plus OB? The distance from A to O and also from B to O. So that is AO plus OB, that is AB. So instead of this OA plus OB, we can write F into A. So the couple of force taking place on this particular rigid body on the action of a force F at the point A and B is equal to F into AB, and this AB, the distance between the two points of action of force, is called arm of couple. Arm of couple. Okay? So the total couple taking place on a rigid body is equal to force, magnitude of force into the multiplied with the distance of separation between the two points of action of force. So that is couple is equal to F into AB. What will be the unit? The unit will be same because it's an addition. Summation is only taken there, so the unit will be same as that of torque, that is Newton meter. Will be the unit of couple. So you can see many examples of couple in your day-to-day life, isn't it? Using key, isn't it? When you open a lock using a key, there you are using the ideas of couple. Then when you are tightening a jar or something, there also we are using these ideas of couple and all other things. A screwdriver, tap, okay, all these concepts are coming under this couple concept. So it's simply in definition I told you when two forces equal in magnitude and opposite direction acting on a rigid body, and the line of forces will be different in action will constitute a couple. There the more will be the turning effect taking place. Clear? So that's about the couple. Clear? So we have discussed about moment of force. Then what are the factors depends on factors on which the moment of force is depending. Then we are seeing what the different types of moments on the basis of their direction, clockwise and anti-clockwise. Then we are discussed the concept of couples. Now we are going to another topic, that is the equilibrium conditions or equilibrium state. Equilibrium. All are familiar with this particular concept, equilibrium, isn't it? So equilibrium means, as Newton's first law says, that every body will continue in its state of rest or motion unless until it is acted upon by an external force, isn't it? So all the bodies will be in their state of rest or in uniform motion unless there is an external force. So that's the idea. If a body remains in its state of rest or motion, then definitely we can call it as an equilibrium state. Clear? So here, now we are going to discuss about this concept on the basis of forces. So if no forces is taking place on a particular body, then we can say the body seems to be in equilibrium. At the same time also, if a body is not changing its state of rest or uniform motion, even on the action of some external force, then we can call it that body seems to be in an equilibrium state. Which means if the net resultant force taking place on that body seems to be zero, then we can call the body is in equilibrium state. Clear? Which means the body, let's consider a table is placed here. So there is forces are there, weight is there, normal reaction is there. So even though the body seems to be in state of rest, there is no change in its position. So we can call it as that table as an equilibrium body, isn't it? So that's the concept. So on that basis, we can classify this equilibrium into two. One is static equilibrium, and the second one is dynamic equilibrium. Static equilibrium and dynamic equilibrium. Clear? So as the name says, static, which means stationary. Okay. So this is the case which is comes for the case of bodies. Then those bodies are rest in state. Okay. The dynamic is moving one, isn't it? So these are the cases coming for the bodies having uniform motion. Clear? So let's consider. You can consider a body which is placed on a table or something like that. Clear? So then definitely the weight of the body will be there, which will exert from central gravity, and there will be a normal reaction force will be there acting in the upward direction. Then definitely if you apply force Fa, even on the application of that force Fa, if the body is not making a motion, then we can call that this body seems to be in rest, and that is called static equilibrium condition. Even on the application of an external force, the body is not changing its position, remaining in its state of rest, then it is called static equilibrium. So you can see if a force is acting in this direction, at the same time there will be an equivalent opposite force will be there, and that force will be given by the friction concept. So there will be a frictional force will be there to act in the opposite direction, and that will counterbalances all the forces here. So such a manner the net force taking place on this body will be zero. So that's the case for static equilibrium. So static equilibrium is a condition in which the body will remain in state of rest even on the action of an external force, which means the net external force acting on the body will be zero, and the body will remain in state of rest. That is called static equilibrium case. Whereas dynamic equilibrium concept. Dynamic equilibrium concept means if a number of forces is acting on a particular body, even though the body is not changing its uniform motion, then it is called dynamic equilibrium. Clear? Which means a body which is in a moving state with a constant velocity, and even we are applied a particular amount of n number of forces were acting on that body that is not changing the velocity of the body, then it is called dynamic equilibrium. So the body seems to be equilibrium or in the state of uniform motion even on the action of an external force, then it will come under the category of dynamic equilibrium. You can consider many examples. A train is moving with a constant velocity, so that seems to be an example for dynamic equilibrium. So there will be a force will be there in the forward motion, engine will create that force that will move in the forward direction. At the same time there will be a force due to the friction and also due to the friction of air that will act in the opposite direction, and that will counterbalance, so the train will move in a constant motion, which means velocity. So that's the example for dynamic equilibrium. Clear? So equilibrium means even on the action of some external forces, the body remains in state of rest or uniform motion, then we can call that body seems to be in equilibrium. Two types of equilibrium are there. Static equilibrium, that's the case for the rest bodies. Okay. Then dynamic equilibrium, in which the bodies are moving with a uniform motion. We can connect with the Newton's first law, isn't it? If there is an external force is required for a uniform motion, isn't it? Otherwise, the body will remain in its state of rest or uniform motion. If you apply a force, definitely it will change its uniform motion and also the position, state of position, isn't it? So even on the application, if it is not changing, then we call them as equilibrium bodies. Clear? Okay. So that's about equilibrium condition. Now we can bring this equilibrium condition. We can bring the conditions for equilibrium, isn't it? You can see static equilibrium, dynamic concept. From there, definitely we can say there must be some conditions for obtaining this particular equilibrium, isn't it? And the two conditions for this equilibrium state are, first one, all the translational forces acting on a particular body must be zero, which means for the case of rest bodies and all other things you can consider. For static equilibrium concept, you can see these are all the translation forces, Fa and Ff. Translation force acting on here R and W. The net translation force acting on this body will be zero. If it is zero, then definitely we can say the body seems to be in static equilibrium. If it is not zero, let's see Fa is more when compared with Ff, definitely the body will move in this direction. So that is not a condition for the static equilibrium. We can't call them as equilibrium bodies. So it will not be possible. So the first condition, the net translational force must be zero. Clear? It must be zero. So that's the first condition for equilibrium. And second one, for the case of translation force, it must be zero. Same manner, rotational concept, which means when a turning effect is taking place, that time also we can bring this equilibrium condition, we can bring the equilibrium identities. So in that manner, if the net moment taking place on a particular rigid body seems to be zero, then we can call that body seems to be in a equilibrium state, which means the sum of all the anti-clockwise and clockwise moment taking place on the body seems to be 0, then we can call it as an equilibrium body. Clear? Or the body is obtained in equilibrium state. So the second one for the case of rotational motion, which means I told you the moment of force. The net moment of force taking place on the body seems to be 0. Then we can say the body seems to be in state of equilibrium. So that's the second condition for this equilibrium condition. The resultant moment of force acting on a body must be 0. Must be 0. So these are the two conditions for obtaining equilibrium state. The first one is all the translational force acting on the body must be 0, and second one, all the resultant of moment of forces acting on that rigid body must be 0. So that way I told you we can bring that idea also, the resultant of moment of force, which means all the sum of all the anti-clockwise and clockwise moment taking place on a body. If the sum seems to be 0, then we can say the body seems to be in a state of equilibrium. Clear? Okay. So that's about equilibrium. Now we are moving to the most important section in this chapter, that is principle of moments. Principle of moments. I told you for equilibrium there is two conditions. One is for the concentric and one is for the rotational case, isn't it? In the rotational case, told you resultant of moment of force must be 0, which means sum of all the anti-clockwise moment and the clockwise moments must be equal to 0. And from there on also we can bring one more idea, that is, if the anti-clockwise moments taking place in the rigid body is equal to the clockwise moment, then we can say the body seems to be in equilibrium. So that's the principle of moments. If we are telling if a particular body is in the equilibrium state, or you on the application of a certain number of force on a particular body, if the body remains in a state of equilibrium, it comes to state of equilibrium, then the sum of all the moments taking place in the anti-clockwise direction will be equal to sum of all the clockwise moments taking place on the body. Otherwise, the total sum of or the resultant moment of force taking place on that particular body will be 0. That's the principle of moments. So we can consider the mathematical verification for this particular principle of moments. For that, we just consider a rod of length L, which is balanced at this particular point F. Okay? Now consider P, Q, and R. With the 3 points on which we are weighing, we are putting some weights on these points here. Clear? And let the weight of the bodies be W1, W2, and W3. We are putting some loads on that particular points P, Q, R. Clear? And this is our balancing point. So we can consider the perpendicular distance. We can call the distance for this particular point P and F be A, and that between Q and F be C, B, and that between F and R be C. Okay? Then what will be about the moments? So for the point P, the force is acting in this direction, then definitely the moment will be in this direction. Then for the point Q, the force is acting in this direction, W2 is the weight, so the moment will be in anti-clockwise direction. Then for the case of R, weight is acting in this direction, so this will be the line of action. We can consider this is the line of action, so this will be the direction of moment. So we can consider this is one clockwise moment and two anti-clockwise moments. Then the total sum of the anti-clockwise moments taking place on this body will be equal to what? Anti-clockwise moment. Moments equals force into perpendicular distance, that is W1 into perpendicular distance, that is A, plus x1 W2 into perpendicular distance B. Clear? This is the total anti-clockwise moment taking place on that particular body. Now, for the case clockwise, clockwise moments. So what about the clockwise movement taking place on this one now? Only one clockwise motion is there, that is W3, the weight acting on the point R, which is making a clockwise moment, and the perpendicular distance between them is C. So it will be W3 into C. So when you place this weight, I told you this body, rod is balanced, which means the body is in equilibrium. So we can say that on that case, the total sum of the anti-clockwise moment must be equal to clockwise moment. So bringing the principle of moments, we can say that anti-clockwise moment is equal to clockwise moment. That is W1 into A plus W2 into B equals W3 into C. Clear? Or we can write W1 into A plus W2 into B minus W3 into C equals C. So this is the principle of moments. If on the application of an n number of external force, if the body remains in equilibrium, then according to the principle of moments, all the anti-clockwise sum of all the anti-clockwise moment taking place on that body must be equal to the sum of all the clockwise moment taking place on that particular rod or rigid body, or otherwise the total resultant of the moments taking place on that particular rod must be 0. Clear? So that's about the principle of moments. So in today's sections we have discussed about the concept of moment of force, directions, anti-clockwise and clockwise direction, and we have discussed the couple of force and the mathematical expression for that. Then we have discussed the conditions for equilibrium on the basis of this moment of force and all of things. Static equilibrium and dynamic concept we have discussed. Then the most important principle of moments, which means on the application of an n number of external force, if the body remains in state of equilibrium, but can be in static or in dynamic, then definitely according to principle of moment we can say that the sum of all the anti-clockwise moments must be equal to the sum of clockwise moments taking place on that body, or the net resultant moment taking place on the body must be 0. Okay, so I will catch you in the next section with some more interesting ideas of center of gravity and uniform circular motion. I hope you are clear with these portions. So till then, I will see you. Thank you.